Hey everybody, welcome back to Davesplaining. I'm Dave, and you are, if you're subscribing, one of 1,000 subscribers, 1,000 plus. I can't thank you enough for staying on the channel, even though I haven't been updating. So it's really motivated me into grabbing myself by the bootstraps and creating new tutorials again. And the attentive mind will notice we're in Houdini, and this is we're not going to abandon everything else we've been doing, but one of the main requests for new tutorials has been to start doing the tutorials in Houdini. So I want to do that for you, at least as a thank you for the support. We want to do our first tutorial in Houdini. And Houdini is, of course, an entire DCC. Some of my tutorials have been, most of them have been in RealFlow, some of them have been in Maya to build the scene or render the scene. So now we're going to do everything in one app. But above all, Houdini really is the go-to for simulations. RealFlow, as much as we love it and as much as you can still use it for some aspects, it is not being developed anymore. I guess maybe at some point it will be deprecated or unusable because the industry is going to evolve. But it's still something I try to go back to for like Diverso or whatever. But Houdini is really an all-rounder and the go-to. I don't think there's any point in doing Sims in any other package, unless it's for the fact that Houdini indeed is a paid app. But there's a lot you can do in the free version. And if you want to learn like the most powerful tool that's still also available for cheap as a premium with the indie license, but especially if you want to give yourself opportunity in the industry or just from the sake that it's just the best for Sims, I really think you should be considering learning Houdini. And the first thing I want to point out is you should go to the webpage, search for Side Effects Houdini, or just go to sidefx.com. And to download Houdini, you click the Get and then Download. And in here, you're first going to need to create an account. And once you've done that, you get to pick between the old installer, which you should avoid. This is just an installer for the latest production build, but it's really deprecated on the legacy method. You should be downloading the launcher. When you download the launcher, I'm just gonna bring it up here, you get this little deployment tool, really, which is what you can use to install Houdini. So if you click the plus button, you can install the latest production build or the latest daily build. There's no real point in staying on the bleeding edge unless there's some kind of very specific bug that you've been waiting to have resolved. Otherwise, I tend to stay on production. I'm on 605, 640 is the latest. I don't foresee any major things. 19.5 is still the major version. So anything 19.5 and up you should be able to follow along this tutorial. From here, it's also easy to install the engine plugins for Maya and Unreal. If you use those, it's going to install the right one in the right place for the right version. I also want to encourage you to download and install the Labs package for the version you're running. Labs is just a set of, kind of tools or node setups combined into tools that can make your life easier. There's a lot of usable things in there that are a bit more, the latest developments and maybe not enterprise level solutions, but it's really useful for small studios and the end user and anyone in Houdini, really, if you don't have any specific requirements. So do install the Side Effects Labs. I'm sure some of the nodes we'll use in this one will be from Labs. So from there, you can also launch Houdini, which I've already done. It's going to grant you with this screen. And since I'll be assuming you're new to Houdini, but we don't want to create this super long and convoluted tutorial where we go through every bit and bob that's needed, we're only going to go through the ropes in order to build a basic scene, sim, cache, mesh, and render. So we don't really need to, explain every single button you can click. And that's why I want you to click the first and second link above all. I mean, obviously get started with number one. In here are some really good tutorials for the basic workflows, some of the methodology and lingo that is, you know, in Houdini. This top one, the secret language, is going to take you through some of the different contexts and concepts that are good to understand. And the learning paths is a collection of tutorials which are a bit more discipline specific. If you want to learn modeling or lighting or fluids or pyro, and then there's going to be tutorials specific to that. And this is a good gateway to find some really good learning resources. Some of the best tutorials channels or providers out there are featured in these collections. So don't shy away from these, as I know oftentimes when you come into an app and it's like, hey, tutorials, and you kind of think it's shit, but these are actually some of the best. The content library is not necessarily something that's very alive, or nor is Orbolt, I believe. This would be scene files and this would be setups, so tools, ready-made tools, but maybe leave those for later. And side effect labs we already know about, but it's going to be a little more documentation. So without further ado, I'm not going to fuss around too much. We're going to go into Houdini. And when you visit the website for the first time, you're going to create an account if you haven't already. And there you can kind of register for an apprentice license. And an apprentice is the free version. As long as you're not using any third-party renderer like Redshift or V-Ray, and you're not doing this for clients, you're going to be all good with apprentice. You're going to be able to do everything you can with the full paid version. You're going to be able to do all the effects, all the procedural modeling. You're going to be able to bring it into the rendering context and render out your project. So really, Apprentice is a lot of opportunity to start learning to use this software for free. And we're going to start building up our basic scene, but first we're going to create a new project, which you do by going to File, New Project. And the project path is really going to suggest something in your home folder, I guess. I'm just going to go and find my own little root directory. And then I have this little convention that I like to do for my project, where you can name this anything you like. So I'm just going to call it Houdini and hit accept. This is now going to set the job variable. If you go to edit, aliases and variables, you'll see on the variables that there's now this job. So whenever we need to reference and want things to land in this directory, we could use a variable, but we'll get more into that later. Let's just save the file before we start. My first sim, maybe. And the default convention is that it lies in the root of the job folder. You see, it's referring to $job, and it's literally just taking you to this home folder of your project. And hit accept, and the file format. So once we've created our first project and scene save, we need to learn something about the user interface. I really want to be bare bones and consider the fact that you're doing this for the first time, and then you go explore on your own. So I kind of want to go slow, and I only want to cover what's necessary for this little project. And you're going to notice when you go out to Discords and whatnot, that there's going to be a sense of gatekeeping around the fact that you're trying to, you know, get started in Houdini and do liquid sims, but this is what we do on this channel, right? So we're going to do a basic scene, basic colliders, basic emitter, basic liquid sim, and then render it, even though, you know, maybe it would make sense to do some of the more basic setups, but just in the latest releases of Houdini, it's a lot easier. You don't have to get specifically into some of the more, you know, nitty-gritty as you've been forced to before in order to just do a flip sim. So we have our basic viewport. We have our node network area, network view. I have probably overwritten the basic build. I think it's going to look a little something like this. We have now two main views in here, the viewport and the network view. I think the default is, if I click this drop down arrow here to split this pane top and bottom, and then I think if I click the plus here, there's different tabs in the same view, but the one that's going to be default, I believe, is parameters. So it's going to be viewport, network, and parameters. And if I could just control click something on the shelf right now, just for example, you're going to get a geometry, and inside of that geometry, you're going to get a sphere. So I just double clicked to dive inside, and then I clicked, pressed U on the keyboard to go back up. You'll see on the node, kind of like level inside, there's a sphere object lying down. And then when I select something, the parameters are displayed up here. So if I go back to the parent level, this is where we typically create a geometry. You can do that by hitting the tab key, start pressing Geo, hit enter to confirm, hit enter again to confirm the location of it. Or if you just want to lay it down, you can just hit shift enter and it's going to be laid down. Really just created the container in which we're going to do all of our stuff. I'm going to call it my first sim and double click to dive inside. And what I mean by that, or what this really is all about, is, let's say you're building, you know, a street, and you have your whole environment, and then inside of there you have houses and whatnot, and then you bring in a character. Maybe you, let's have, say this tube represents the character. Maybe you have a different geometry container for the character, and kind of build up the complexity like that. And then when you go inside an object, you can use the buttons here to hide or show or ghost the other objects. But that's not ultimately important. I just want to kind of bring that point home, while we do want to do everything in one single geometry container in this one. So tab, geometry, shift enter, my first sim. Even if you space, it's going to default to underscore, because it doesn't want any spaces in the names. And then we dive inside. And this might feel a bit alien to you, but if you consider, if you've been using Maya and you've been extruding and, you know, beveling and whatnot, in fact, underneath the hood, this is essentially what's going on. And you can kind of see that if you twirl out this tree view that is hidden by default, I think. If it isn't, then you can always just bring up the paint type tree view. It's kind of like the outliner. You can see now in the OBJ, like what you're seeing here is you're used to seeing in Maya everything that's under the OBJ, all the object, all the lights and everything. But we're not going to dwell too much about the differences from other apps. We're just going to start building up our scene. So I'm going to lay down, just as they did with the default demo object, when you click the shelf, I'm going to lay down a sphere. And the sphere is going to have a set of options with it. I'm just going to, and by the way, navigating in the viewport, Alt, as you're probably used to from other apps, left mouse to orbit, middle mouse to pan, and right mouse to dolly or zoom. You can also use the space key on the keyboard with the same combination of mouse buttons. And then another thing you might want to know is you can use space 1 to go to perspective, which we're already in, and then 2 for top, 3 for front, 4 for side, or 5 actually for UVs, and then 1 back to perspective again. Another thing you can do is space B, and that's going to take you into this kind of classic quad split that you might be used to. And then you can hover over one of the viewports and space B to maximize. But personally, I don't really use the quad split anymore since I went into Houdini, but you can if you want. So we've laid down our sphere and we can pan around and see what's going on. I'm going to assume that the grid plane, where y is 0, is where our collider is going to be. It's going to be colliding with the ground. And this sphere is going to be the emission source of liquid. So we could be changing the values of radius here. You can go into any of these fields and you can start editing them. But what I like to do is use the middle mouse key. So if you either on the mouse hover over the attribute name and use the middle mouse button to click and hold, and then the nice thing about Houdini is we have this value ladder, and this comes in handy when, let's say, you have a macro scene and you don't want to be changing it by increments of 0.1, which is the default. You want to be changing it of 0.001 or 0.0001. Then you can go to the lower parts of the value ladder, and once you get to the increment that you like, you can scroll right to increment or left to decrement. So really keep holding that middle mouse button and find the increment makes sense to you. If you're in a huge environment and you want to be changing the scale of a mountain, maybe you're doing it by increments of 10 or 100. So that's a really handy way of tweaking values, and you can do it on the attribute, which affects all of the channels at once, or you can do individual channels. So if I just want to change the Y radius, I can change it non-uniformly, like so. I can also change, for example, the center, and if you're unsure what it does, just try it. Nothing's gonna explode. But I don't really want to change the radius here. I want to revert to defaults by control clicking or control middle mouse button on the actual attributes. But I want to change the uniform scale instead, because I don't need to change the shape really. So we created a sphere, and with the parameters on the sphere, we changed the uniform scale. Let's round it off to 0.25, and let's leave the center at 1. So it's 1 unit above the grid. Now I don't really want this type of sphere that has poles. I want to change the primitive type to polygon. This is something you're going to see frequently in Houdini when you want something that you can deform without having pinching at the poles. And then instead of rows and columns, you have this frequency attribute that you can increase just to get it to look round again. And that's good. That's the start for our emission geometry. This is what we're going to use to emit the fluid. And we want to start thinking about some kind of collider object. We want to collide with the ground, but we want it to be a little more interesting and lay out some, objects for it to collide with. So I want to start creating a grid now. So I'm just going to hit the tab key, start typing grid. It auto-completes the grid for me, or whatever suggestions it has. And I'm just going to shift enter to lay down that grid. And now we need to consider the concept of the view flag. The blue part of each node is what is called the display flag, or the view flag. And it really is, what you want to see and what you want to actually be active. Because let's say I move the view flag to the grid, we can no longer see the sphere. And that's fine, it's still there, it's just not what we're looking at right now, or what is being used right now. We can always template as well, which is the pink area. So even though we're working with the grid, we can be mindful of where the sphere is. And that's good. We can leave it like this. It's kind of wireframing the sphere for us and showing us the grid instead. Now I want to lay out some objects on the grid. I'm not going to use the grid per se for anything else than a means of laying out other objects. So let's consider something like a box. Let's hit tab and put down a box, shift enter. So realize I had the sphere connected, selected, and by hitting shift enter you actually connect to the object that you have selected. So I'm just going to undo that by severing this connection. So I don't really need the sphere to be influencing anything with the box. I just want to lay out the box. I'll be highlighting the template flag. And you see we no longer see the sphere because we can only have one view and one template. And the box is something we're going to be positioning across the grid. So I want the box to let's say we want to change the size or the uniform scale. Probably want it to be non-uniform, like a standing rectangle, like a milk box or something. So I want to be changing the aspect ratio, kind of. I want to be twice as tall as it is wide. Now, potentially I want to change the scale at some point. Potentially I want to tweak the center so it's always sitting on the ground plane. Well, this is going to be a lot of back and forth, and if you've been watching some of my tutorials, you've seen where I use the size, and I take half of the size and I change that to the center. But that's just really inconvenient and a lot of work that we don't need to do when we're in Houdini. We can just freely tweak the size, the scale, and we don't really need to bother about the center because we can do this later with another node. And another node is match size. And I do believe this one is actually in labs. So if you don't see it, make sure you have labs. And I hit Shift Enter because this time I wanted it to be laid down. And if you failed to hit Shift Enter and just enter and it's laid down like this, the only thing you need to do is click, and you don't need to hold, and you do input it into, in this case, the left port, which is the geometry to move and resize. You'll see that in the tooltip. And we let go, and now it's connected. But we don't see anything. And that's because we don't have the view flag or the template flag on the match size. So in this case, I'm happy with watching the wireframe. So I'm clicking the template flag of the match size. Nothing is really happening though, because we haven't made any settings. The only thing I want to do is change so that the minimum value of this object is going to be offset to really the minimum of what? The input, or if nothing is input, well, the scene really. So the minimum of this box, I change it, and instantly it has been aligned so that whatever changes we do now, if we select the box and tweak the size or tweak the scale, this is always going to be, you know, moved. You even see the highlight here because we have the view tool or the tool handle selected, which is what you want to use if you want to graphically change the properties of any objects. So if I select the sphere, I can, with the tool handle, instead of tweaking the individual attributes, I can change the position, and this is going to alter the X center or the Z center or the Y center. Or if I start playing with the size here, that's going to affect the radius. But we don't really need to change any of these for now. So we're going to undo them. But you can always see like the highlighted wireframe and the tool handle that we can play with the size and the scale and the position of our box, but ultimately the match size is going to come after and put it on top of the grid. So we kind of have one box that we want to play with and see if this gives a nice result when we duplicate it across the grid. And you're going to do now one of the most common that you're going to workflows that you're going to encounter in any other Houdini tutorial, which is copy to points. So we're going to take, hit tab and start typing copy. And here's when it can be really, you can be really clever with the search function in Houdini. I can do co and then po I, and really there's only two nodes that has co followed by poi at some point in the name. You can be really, you don't need to make stars or spaces or anything. You can just really type really freely whatever characters you know are unique to the node you want. I want to copy the points. I'm going to hit enter because I don't want it to auto connect. It wants the geometry to copy, which is going to be the box. And it also wants target points to copy to. Let's just put that. So this might not be what we want, but there's a reason for why the objects are where they are and the way they're facing. So let's look at the grid and consider the grid for a second and move the view flag to the grid. If we, on the right-hand side in the viewport, we have all of these tools that are really a way to change the way that the scene is being displayed. So I want to be looking at the points. You see copy to points. These are the points. The individual points where the edges of the object meet is where we're now going to be copying objects to. But that's not necessarily what we wanted to achieve. I don't want a regular grid pattern of boxes copied. I want them to be kind of randomly scattered across the grid. And the hint is in the name, scatter. We want to type scat and then just hit enter. And whenever you have a node that is, unconnected, you can drop it on the noodle of an already existing connection and let go. And this has now been, put in between the grid and the copy to points. We're now scattering to randomly position the objects rather than on the points of the underlying geometry. And we also see that the default is thousands, and we necessarily don't want that many. Maybe we want a little less, let's say 60. And then we go back to the box, and then we can say that we want it to be a bit bigger and maybe a bit taller, like so. So maybe this will be interesting. Let's see. We can always come back and change this after the fact. They also didn't orient the same way, and that's just because we're now scattering and not really considering the normals of the object anymore. So effectively, the scattered points don't have any normals, so we don't really orient the box anymore. It's just going to be oriented the same way as the underlying object. So we're taking a grid, we fed it into a scatter, and we have said that we want 60 copies, and the output looks like this. So another common practice inside of Houdini is to utilize nulls. And nulls we're used to in other apps to be kind of like the group object. You group things in order to be able to clear up your clutter, or maybe have this single point of interaction when you want to animate a group of objects. In Houdini, it's kind of the same, but also a bit different. We lay down nulls in order to have this single point of reference. I'll just call this collider. And now, if I do any changes upstream, once I'm referencing this object into the simulation, I don't need to re-reference it to any other new updated object. I can just do all of my changes upstream, and it's going to still be the same. We're going to do the same just for organization's sake with the emitter. This is going to be our emit object. And whenever you have a node that is connected to, I just alt-clicked and dragged, by the way, just as you can do in any of the Adobe apps and a lot of other apps, to copy the null. But I don't want the null to be connected to the copy to points anymore. I want it to be connected to the sphere. So anytime you have an existing connection, you can just click the connection itself close to the output port there and hold and drag, and you'll see now kind of creating an elbow on that connection. And when I drop it where the sphere is, there's a difference if you drop it on the port and then it reconnects, or if you drop it kind of on the node, in the middle of the node, then it's going to bypass through that node, and that's not really what we wanted. We don't want to feed the copy points to a sphere and then to the emit. It's not going to do us any good. We want to drop and release on the output port, and now it's been replaced. So once we get into simulation land, we can reference our emitter and we can reference our collider. Another thing about view flags, we've been talking about how to change what we view, how to change what is wireframed, but let's say we do actually want to view the emit and the collider together. How can you do that? Well, it's kind of like in Nuke, if you've been in Nuke. You merge any object, kind of like doing a layer. You merge any geometry stream by creating a merge node, and you input all of the objects you want to be seeing at the same time, and then you move the display flag to that new merge node. And if I just unselect and unhide my points, I can see them both as shaded objects together and reference them together, really. This is kind of like combining in Maya, but a lot more versatile. Now that we can see them together, we can keep that just for debug's sake if we want. I want to start setting up the nodes required for the simulation. And this is going to be really simple because in Houdini 19.5, SideFX released SOP versions of basic liquid setups. So unless you have like a huge ocean simulation with whitewater, you can do a lot of the sim right here in this OBJ context where we're currently working. OBJ is commonly referred to as SOPs, and SOPs is surface operators. So it's kind of like saying we're doing it in wherever we're doing our geometry manipulation, but we don't have to lay down this DOP network, which used to be the case before. If you wanted to do liquid sim, you had to drop down a DOP net and dive inside of that. And the rules, how you connect things up, are a bit different than DOPs. So for us, since we're doing our first project in Houdini, we don't really want to be diving into the DOP net. We don't want to be utilizing this new way of working, or I mean, not new to us because we haven't done this before. We're just going to do liquid sim here in OBJ context. And just to avoid any confusion, I'm not going to really go over them. I'm just going to leave it at the fact that, you know, there are different contexts for different types of work, like materials and images, but we can really do everything in the OBJ context up to the point where we want to render, and then we're going to go into the stage. The stage is often referred to as LOPs, or light operators, and in the stage context, we'll be working in Houdini's Solaris framework. That's handy to know if you want to look for tutorials or resources later. We're going to be working in Solaris, and we're basically going to bring our scene into USD, Universal Scene Description, which is pioneered by Pixar, and which is just the underlying data format that is being used on the stage or in Solaris. And there are basically any renderer for Houdini will nowadays support the stage or Solaris. So you can render in Redshift or V-Ray, but it's still going to be available in the stage. Whereas before you used to do this and out. So we're not going to touch out. We're just going to go from OBJ and then into stage, and we're going to create our lights and our materials in the stage and render out our image sequence from the stage. For the rest of this tutorial, we're going to stay in OBJ and then go to stage. And we're going to hit tab and start typing flip. So flip is a set of SOPs nodes that were not available before 19.5. Then you had to lay down a DOP network. And there are a bunch of nodes that we need to know about in order to make a working flip simulation, like the solver, the collider, and the boundary. But we're really only going to take one of these flip options that are suffixed with configure, and then flip or lava or tank. I'm going to pick the top one called configure flip. Flip, configure, flip. It's going to think for a second, and then it's going to lay down a series of nodes for us, which are altogether just a working flip simulation setup. And don't be intimidated by all of these nodes. We're gonna go over what we really need to replace and what we really need to input in order to have this working inside of our scene. The first thing I want you to be aware of is that when you have a lot of nodes that you want to move and lay out and organize at the same time, you can hold the shift key to create or to move any of the upstream connections. So I'm really tugging the bottom node here, but as I'm holding the shift key, rather than moving just the node itself, I'm moving the whole network. And this allows me to be, you know, a little more encompassing and move all of the nodes at the same time. You can do the same or the vice versa by selecting the top node and holding the control key, and then you're moving everything downstream, which in this case is everything except for the flip tank, because the flip tank comes into the flip boundary node from another stream. So what do we have here? If we look from the bottom, we have the surface, which is the mesh that we're going to use to render. We have a file cache, which is just a node that you use when you want to save the simulation to disk. We have the fluid compress, which is always necessary to avoid remove unnecessary data before you mesh. And then the flip solver itself is where the simulation is happening. The flip boundary and the flip tank. I'm going to leave the flip tank. It's just one of these necessary nodes where the only thing we're going to change in here is the viscosity and the particle separation, which we'll get to later. The flip boundary in itself is where we want to input the geometry that we want to pour liquid from. So currently they are inputting a test geometry, which is called rubber toy or flippy, which is one of the default Houdini. Just if you type test, you have a bunch of test geometries that you can play with. So we have a test geometry rubber toy. I'm just going to delete it. They then subdivided to get more resolution, which I'm also going to delete because we can set the resolution on our sphere. They have set color, which we can use, but we don't need to use the set color. We can do that later. And they are also changing the viscosity on a point level. But this is with a wrangle node. And when you lay down the wrangle node, you kind of have to type a Houdini vexpression, which is just short for vector expression language. And we don't want to do any vex because this is a beginner tutorial. So with the flip configure flip workflow that is being laid down for us, we're going to delete everything down to the set viscosity node. And we could see that all of those objects were plugged into the fourth port of the flip boundary. So I'm going to click that output port, and then I don't need to hold or anything. This is now looking for the input. While I have this selected, I can use the middle mouse key to pan around in my network. And I want to input the emit object of my network. So I've now, if I take everything upstream from the merge by holding shift and pull it over here, I've now plugged in the emit null, which in turn is being fed from the sphere, into the flip boundary node. And this is going to turn the sphere into liquid. So let's see what we have if we start thinking about running the simulation. I want to change something first because we deleted this node that was doing some expression magic and changing the viscosity. I want to disable this varying viscosity node because it's going to be looking for an attribute that tells us which viscosity it has. And instead, the viscosity is going to be set by this value. Let's not do any viscosity right now. We can come back to this later if we like to. I'm just going to highlight the flip solver. And that's going to show me really what the solver is seeing. And we can already see, if we go in here, you can select the flip solver node. You can also see a blue grid, which is a default collision plane. And if we go into the collisions, we can see this ground, and it's been set from none to ground plane. And the ground plane is going to default to -2, but we've already moved our sphere up by 1 unit, so I'll center it at 0. The way a simulation works in Houdini, if you just want to run it and see it, if it's not too high res or anything, you can just hit the play button on the timeline. And since this is really low res, there's only a few points, we want to address the fact that they're black, but we can see that there's actually something going on. There's particles being emitted, they are pulled down by gravity, and they collide with the ground plane. You can see that parts of the timeline turns blue, and this is similar to what we're used to seeing in Maya Bifrost, for example. These are now cached, so we can really just scrub the timeline to see them. But at any time we want to go to a point where there is no blue, it means that if we click, let's say, frame 192 in this case, Houdini is going to need to figure out the computation of these frames before it can show me frame 192. In this case, that was really quick, but once we start getting into more granular particle settings, this is going to be heavy. And you really want to avoid clicking ahead in the timeline, because then Houdini is going to need to simulate to figure out the result. So we've seen how to play back a simulation. We don't really like the detail. We don't really like that it's colliding only with the ground plane. And we don't really like the fact that the particles are black. So let's look at a few ways to make this look nicer. I'm going to go to visualization, and rather than looking for an input color, I'm going to color by speed. And this way, it's going to take the speed of the particles and shade them from a value of blue to white, which is going to be the fastest particles. If a particle reaches 5, it's going to be completely white, a velocity of 5. And we're going to look later at how to debug this information. But let's just leave it at default for now and just play it one more time. You could see when it was splashing, it was getting a bit brighter. But it wasn't really getting white, and that tells me that we should be lowering this value if we want to see any white particles. So let's just lower it slightly by just clicking the handle and dragging it downwards until I see some white. I don't want them all to be white. Basically cut this value into half or a little less. And now we can see that as they start falling, they all turn white, and then as they've landed and slow down, they go back to dark blue. This is a behavior we're used to seeing from RealFlow, for example, and even Maya. So we've gotten rid of the ugly black particles, but now we want more particles. So let's go back to the flip tank node. Particles are dictated by how much separation between each individual particle. If we go back to the first frame of the simulation by clicking this first frame icon, which looks like the rewind to start icon on your VCR, DVD player, whatever, you want to do that before you change this grid scale, because otherwise it's going to, if you end up putting in a really low number, which create a lot of particles, it's going to need to figure out the sim all the way up to the point where you were currently at the timeline. So it's good practice to go back to the first frame before you change the particle separation. Now I want you to be aware of the fact that this is not a linear value. If I change to 0.03, it's not going to create twice as many particles. The amount of particles is going to change exponentially. And what I mean by that is, particles are distributed in voxels. A voxel is the shape of a box, and the voxel fits particles in X, Y, and Z. So if you change the particle separation, it's going to change them in all 3 axes and really going to fit a lot more particles in than twice as much. We can actually see the particle count by going down to the flip solver node in this case and click and hold the middle mouse button. This is off screen for me, so I'm going to instead hover over and click the eye with the left mouse button, and that's going to give me a window that remains even if I let go of the mouse button. So I can now drag it into the scene, and now it should, if I middle mouse, be on the screen. So the quickest way is just going middle mouse, but if you need the window to stay there, you hover and then left mouse the eye. You can also click Control middle mouse to get this hovering window. So we're looking at fluid particles. We can see that this sim has points. Points is the same as particles in Houdini. We see a whole lot of other information that we don't need to be concerned about at this stage, but we can see that there's 238 points. And from my previous tutorials, if you want a good detail, you're going to need millions of particles, really. Let's remember 238 and go to half, 0.03, from what they had set up. It instantly changed. There's still not a ton of particles, but it's 2,501. If it would have been a linear relationship, we would have ended up in the 500s, but now we've gotten roughly 20 times as many particles, even though we just changed the particle separation to half. So I think we can afford at this stage, even though we don't really need to get to the final result right now, we can afford to pad this down even more. So let's control middle mouse click And okay, it's going to disappear anyway when I click another node. Let's go to 0.02, and we got 8,000. Let's go to 0.01, and we got 69,000. I'm going to go a little step further, 0.005, and now we should have quite a lot of particles, 500,000. This is going to be enough, and you know, if your computer starts struggling, then you can stop at 0.01. Because flip simulations really does take a lot of computational power, and above all, a lot of RAM. But let's now click the play button again, and you'll see we can no longer see this in real time. But it computes fairly quickly anyway. So you'll see the splash now have a lot more interesting detail. Kind of like a water balloon pop there on the ground. And this is really interesting. This is something we can start figuring out how to cache, mesh, and render. We can still click, and we can still come back and play it. If you want to make sure that, you know, now that it's been calculated and stored in cache, it still plays pretty quickly, the frames that are actually cached. In fact, they play too quickly. They don't play the FPS that the scene is currently set to. This icon down here with the window and the mouse cursor is the global animation options. We have an FPS of 22 and a frame range of 1 to 240, 10 seconds. We don't really need to be rendering out that many seconds. I can leave it at FPS 24, which is the default for film, but I'm going to cut it down to, let's say, 96, and apply. Now the timeline only has rough 100 of frames, but it's still playing too quickly when I'm playing it back to cached frames. So I'm going to click this clock here, which is the real-time toggle. So it's now going to make sure that it's playing at the intended frame rate if it can. So now that we have a little bit more frames, half a second worth, it's going to play those frames at the real-time speed. Now it's really dictating how many frames we can actually see at the same time, and in real time is your RAM. So if this blue line starts eating up the early frames of the sim, you can no longer see the entire frame sim at the same time. And then we need to do one of two things, either going to the flip solver, and in the, let's see, I always forget where this is, the setup, there's a cache memory. So it's currently set to consume 5 gigabytes of RAM. If you have enough memory, you can just increase this. But at some point, you're also going to want to save it to disk, because we don't want it to be recalculating this point cache every time we change something in the sim and want to update the mesh. So then we want to cache. So Houdini's been nice and put down this fluid compressed node for us. It really is doing a lot of things behind the scenes. What we need to be concerned with is really that it's removing unnecessary data that is needed to do the sim, but not the mesh. Because now we want to take the result of this fluid compress and cache it before feeding it into the mesh. We can still view the mesh now, but it's just going to take a lot more time. At some point, you are going to want to cache this. So I'm going to select this file cache node. The file cache node is the same for whatever you do, even if it's a fluid sim, a pyro sim, a particle sim, you know, a set of really dense geometry that you don't want to be recalculating again. It's always going to be the same file cache node. And it's preset to cache into the directory hip, which is where the saved file is located, and then a subfolder called geo, a subfolder called hipname, and a subfolder called os.f.bgeo.sc. I think actually I have overwritten this result, so it may be something like this as the default, but I prefer to have it like this. I'm going to break this down for you. So hip is where the save file is located, geo is the subfolder, and then hipname. I don't mind if the folder is called the same thing as my file. So if I do start creating other scenes in the same project, they get their own subfolder in the geo folder, which is the convention. Anything you cache, even if it's liquid or fluid or pyro, it's going to be in the geo folder. And then in the subfolder called hip name, the same as my first sim without the extension. And then OS. $OS is a variable that means object string. Object string is the name of the node. So I'm going to call this, let's say, water balloon. And then point or dot, and then $F, which is just the current frame. And then .bgo.sc, which is the default file format in Houdini, which you shouldn't be changing. Just bgo.streaming cache, I think it's called. And it's really just the most efficient way of storing this kind of data on disk. What's really nice is just to middle click the geometry file attribute, which is going to show you the resulting path. And really just my product folder, and then where the hip is, and then geo, and then my first sim as is the hip name, and then water balloon, which is the name of the node, .41, which is the current frame, .bgo.sc. But if we don't want to just save the current frame, we want to save the whole frame range of 1 to 96, because that's the global animation options. And once you've gotten that far, you really are good to just file, save, and then you can either click save to disk, which is going to hog the whole Houdini interface for you, so you can't really do anything else. It's going to bring up this little window here. It's going to benefit from the already cached frames, and then you can't really do anything before this cache has finished, which is fine for this case. But later on, I'm going to show you why I prefer to use the save to disk in background, because then you can keep using Houdini. And it is also a slightly nicer node in a sense that it shows you the progress right here in the network view. But let's leave this one to finish cooking. The cache is done, and I can watch it if I move the display peg to the water balloon, but the display is no longer going to be points. It's going to be kind of like the underlying information that is being derived from the fluid compress. So it's really better to just move the display flag to the particle fluid surface at this stage. And it's going to take the cached result, and it's going to create the mesh for this frame. And that can take a few seconds. It's doing a bunch of volumetric magic, and it is ultimately going to show me after a few seconds the resulting mesh. And typically you don't need to play around too much with these values. I'm going to show you some of the settings later on, but I'm just going to leave this to compute. And once it has, you'll see that this has now obtained the same color as the underlying particles. But it took a little while, and I don't want to be waiting all of that time. So I can either create a new cache to cache out the resulting mesh, which is probably what I want to do. So I'm just going to Alt-click and drag. And remember, I didn't go back to the first frame. So now a bunch of things are happening, and I'm not sure exactly what. Probably the file cache is being plugged into the fluid compress, but I created a new one, so it doesn't really have anything on disk with that name. So what you can do, first of all, is make sure to go to the first frame before you change any connections. And if something is taking a lot longer, you can use the escape key. But once your scenes start getting really heavy, there's always a risk if the scene goes unresponsive and you click escape to kind of cancel the current calculation, that it crashes. So you want to be careful with that and make sure you do your changes on the first frame. Another thing you can do is go down here which says auto update, and when your scene starts to get really heavy, you can set it to manual, so then when you change a value, it's not going to change automatically. Kind of like in RealFlow when you right click and build after changing some value. you now have to click this refresh button if I change the value. But this is not the case with this scene. So I'm just going to say cache the particle fluid surface and call it water balloon mesh, and really save the scene, Control S, and then save to disk in background this time. It's going to bring back this little nice UI, and it's showing me that it's currently done one frame as 95 remaining. I paused the recording and let it run a few more frames. You'll see now we have 3 done, 2 in progress at the same time, and 90 remaining. So we can now be moving the view flag to our water balloon mesh and look at one of the first 4 frames which are done. You'll see this is now a liquid mesh. It's not too much to write home about at this stage, but let's let this finish, and then I'll show you how to create a flipbook similar to a playblast. The cache has now progressed around 25 to 26 frames or so I can move the view peg to the water balloon mesh caching sequence, and I can see that now I'm able to play this back fairly quickly. But it can also be nice to be able to see it in real time, even if it takes a lot longer to calculate and read it. Just basically reading a heavy sim from disk can mean it's no longer possible to view in real time. So then you use Flipbooking, which is just Houdini's way of Houdini's name for playblast, as we're used to seeing it. Flipbook with new settings. The only thing I really like to do is disable resolution, because otherwise it's trying to fit the current viewport, which is obviously not a 16:9 or anything, into some kind of default resolution, and I don't want to do that. I just wanted to put it at the same aspect ratio as it currently is. The rest I don't really see any need to change right now. So with the water balloon mesh display flag ticked, I'm going to hit start, and it's going to start flipbooking. And I'm going to stop this before we get to the completed frames that have been meshed. And you can see already that it kind of blacked out on me there with video memory, because it can be intensive for the computer to handle all of these polygons. But I'm going to cancel now at around frame 30 or 31. Even made it a few frames into what I hadn't cached. But that's just going to leave blank frames. And what you did notice probably is another window popped up, which is kind of like fcheck in Maya or whatever you like, but it's a lot nicer, to be honest, than any other playback solution I've seen so far. The preview in RealFlow, the playblast, the flipbook in Nuke, or whatever you call it. Because this one, you can play back in real time. You can also open up things like a sequence on disk. You can also export from here. But something that's really nice, if you pay close attention to what happens if now that I've disabled resolution, I don't need to bring this window up again. I can just click the flipbook. And as soon as the window pops up, I'm going to bring it back into view. And you'll see I can now start playing back. And it's going to append any new frames that gets calculated to the playback, which is really nice, because in Maya you would have to wait until the whole sequence was playblasted before you could actually start playing it back. Now you can see as far as you've cached into the flipbook, and then keep appending it with upcoming frames. So mplay is a really nice playblast flipbook tool. So this is what we have, and it's taken a while because there's a few polygons involved. Let's go to the last frame, 37, and just middle mouse and see. We have 300,000 points. We can't really see the particle count because it is storing this in a nice way called packed, which is really Houdini's way of saying that you're not able to manipulate the points directly. We're just saving this to disk and reading it back as a single point, not a point, but as it's kind of like a proxy, as you might be used to from V-Ray or Redshift. A lot more efficient to read in when you're rendering. but if you need to do any adjustments, you need to unpack, which is not something we're going to cover in this basic tutorial, but you should be aware of that terminology of pack and unpack. Pack is a lot more efficient in terms of memory. But we don't really need that many frames. There's not too much interesting going on this side of this half of the sim. So I'm really going to cancel the cook, which is going to kill that process. And now we only have the frames that we completed, and the other ones are going to go blank. In fact, what I'm going to do, since this whole thing becomes static after frame 44, is I'm going to go into the global animation options and change to, let's say, 48. So now we're just doing 2 seconds. I'm going to close. Yeah, so we can scrub this back. But remember, even though there's some nice detail here, this wasn't what we set out to do. Remember all of those nice collision objects we put down. So if we look at the water balloon mesh and move the template flag to the collider, this is what we want, right? We want to be colliding with these collision objects here, these boxes. So I'm going to look at it from the top and make sure that, you know, we're not dropping it on top of one pillar. We're dropping it between. But then I also feel like if we look later in the sim, it's never going to be bigger than this. So the scale of our collision objects is probably way too big. So this is where it pays off to be working procedurally. I can go back to the grid and just middle mouse and change the size. And this is something, probably something like that is probably all we need. Now we can go back to the scatter and lower the total count. Now we want to be going back to the first frame and try to make this water balloon or volume of liquid land in between, just because I think it will look nicer. So what can we do about this? Well, either we can start moving these points around to, you know, predictably change the layout of our colliders, or up here in the global seed, we can change the random distribution of the points. So we can try to find a distribution where there's no box underneath the balloon or the volume. That can be tricky though. So something you can also do, I think maybe it will come down to a combination of all of these methods, but something we can also do is to scale the radius that this relax operation is considering. So what means relaxing really is just trying to space them out more evenly. If you maximize the amount of iterations and the radius, they're just going to be very predictably laid out, eventually just turning them back into a grid like before. But maybe we just want a little bit of more relaxing. So now it's kind of going to land on the edge of those two colliders, and then the most of it is going to land in between. This will probably be a lot more interesting. So we need to either make the colliders shorter or move the sphere up a bit. I'm just going to do the latter. 1.2 should be enough, maybe. It'll probably take a while to recalculate. And remember, we're looking at the water balloon mesh, which has been cached to disk. So that's not going to be seen here in the scene until we recache. So I'm going to move the view flag to the flip solver now. And now we can see the result of that. Probably want them to build up a little speed before they hit, or nah, maybe let's leave it as it is. Now we need to figure out how to take these objects and have them act as the collider. I don't really need to be seeing them all together anymore, the emission and the collider, so I'm going to delete the merge. And then I'm going to take the collider object stream, hold shift and move it a bit closer. And now what you need to do to have them collide with an actual polygonal object and not just the ground plane on the solver is just make a little room between the flip boundary and the flip solver. Select the flip boundary node, hit tab, start typing flip, and then I know I want collide, so I can go and then I can just shift enter. It's going to lay down, and if I just tug it, it's going to connect itself in between the boundary and the solver. Now, as long as it's, you can verify it's in between the flip boundary and the flip solver, the only remaining thing you need to do is to take the fourth input, which you can see the quick help there, new collision geometry, and just plug in the collider. Now you can effectively see that since I have the flip solver selected and visible, you can actually see that these objects are not contribution to the collider. They're being remeshed in some way that we currently haven't explored too much about, but we can just safely assume that they're going to be colliding. So I think, yeah, let's see how long it takes to just flip book a few frames of this rather than caching it out. So a bunch of liquid gets stuck on the tops there and then rain down on the other side. And then the rest falls down. And we can start playing this in real time now. And any new frames are going to be added. Yeah, I'm not sure about the behavior, but let's leave as is for now and just kind of take this to the next step before we change anything further. Because this is really the strength of Houdini, is you can constantly, you know, change the inputs, have everything just update and reassess. So I want to close my flipbook. I'm just gonna let the water balloon file cache complete again now that we've changed the collision geo. And now I'm just patiently gonna wait for it to finish, and then I'm going to start the water balloon mesh cache, because it's dependent on the fact that the water balloon particle sim needs to be completed first. So if you start this and it catches up, then you're just going to be stuck with a few frames without meshes. And then you can of course change the start and end range, but why do that if you don't have to? In the meantime, I'm going to add a null at the end of this stream, and I'm just going to call this liquid, and this is what we're going to reference later on when we get to the point of importing this into the stage and setting it up for render. And whatever happens upstreams, we don't have to change anything if we reference this null. So I think by now it's completed 35 frames. I should be good to start the water balloon mesh. And now I'm just going to leave this running for a while and come back once it's done. So I'll see you then. So now it's completed a few frames of the meshing up to this point, or another frame or so. Nothing is set in stone. I'm not saying I'm happy with this, but I want to move into Solaris so we can start figuring out how this is going to be rendered. I want to go to Build and Solaris. This is going to change the layout and bring me into a Solaris viewport, which we'll touch more upon. It's going to include the scene graph tree and the scene graph details into our UI. And something I've done here, you're going to see we have a new network view for stage, but I've also included my network view for OBJ. And the way I did that was the same I did before, where this was more or less just one pane, and I just click the drop down and split it left, right. And then what you want to do, if you have multiple network views like this, by default it's not going to be pinned, so they're going to show the same. And if this is not going to make sense right now, but I'm going to show you a bit later. If I go back to OBJ, for example, both of them are going to go back, and this is not what I want. I want one stuck in OBJ, so I can keep the overview of my nodes here, and the other one, see, now I pinned this one, they're no longer being updated in parallel. So now I can build my stage or my lops or my Solaris scene graph in here, and I can still have access to my OBJ nodes. And the thing we want to do is we want to recall how I told you that the OBJ context is also referred to as SOPs. Well, this is what we're going to do. We're going to import from SOPs. And the way we do that is go into the stage, make sure the mouse is over the stage window, and hit tab and start typing SOP and then pick import. Shift enter to lay it down. SOP import is going to take a node from SOPs into LOPs. And you know, that just makes a whole lot of nonsense for us if we're new in Houdini, but just rest assured this is how you take something from SOPs into LOPs. And we're just gonna, with this one selected, you see the options up here. SOP path, you can either click and go to OBJ, my first sim. You'll notice how everything that has capitals in the name is filtered to come first. So that's why you want to put nulls, and that's also why when I wrote it all caps, it's going to show up first. So I want to import the liquid. And then I'm going to be needing to reference this later on. So I'm going to rename it liquid. And I'm just going to alt click and drag. And another one for collider. And this time, instead of clicking and browsing, I'm going to go to SOPs, and I'm just going to click and drag and hold. Make sure you click, drag, and hold, because if you just click, it's going to select it there, and then it's going to pop up here in the network view instead, the way I have set it up. So now that we are effectively in Solaris, you can see that this is kind of a rendered view now, even though we still only have you know, the viewport look and feel. But we can start adding lights and materials real quickly, and you see this is the difference from the standard OBJ viewport, is we now have the opportunity to render in Karma, Houdini GL, or Storm, which is a GPU renderer. But we want Karma, and we also want to utilize our GPU. So we can press the D key inside of the viewport to on the render tab for Karma, we can choose XPU engine beta, which, you know, in my experience is quite stable. There are some things it can't do yet, but it's fairly promising. And we want to see these two together, obviously, so we can do a merge, just as we did in the OBJ context. A shortcut for merging nodes is if you select all the nodes you want to merge, hold the Alt key, click and drag from the output, and let go where you want the merge node. So you now have a merge node. Let's march the display flag to the merge, so we can see both the liquid as well as the collider objects. Now, let's start adding some lights to figure out how this is going to look. So let's pull out the output port and start hitting tab, dome, light, and hit enter, and then automatically it gets connected. So you see there's no change, and that's because the view flag is not on the light. So if I move the view flag to the light, this is just an all white dome now, and you start seeing lights traveling through the scene. I'm going to add a texture that's on the dome light under the base properties. Texture is where you plug in your HDR. And you can either go to, on the left hand, it should be a default to go to HFS Houdini pick / HDRI. There are 3 HDRIs here, but they're not great. And one tip that I saw somewhere, I've actually kind of forgotten, is you go to Houdini materialX, resources, and lights. And in here there's a few more interesting ones, but they are kind of outdoors. They're pretty good HDRs. We don't want outdoors, we want indoors. So we can go to HFS, Houdini, pick HDRI. These are the default kind of like shortcuts. So we can use the skylit garage. And in this one, the light comes from above. And the only thing we need to do now, I think I want a ground plane rather than seeing the ground of the HDR. So rather than importing, I'm just going to do grid here. And that's created for me a SOP create rather than a SOP import. And inside of that SOP create, there's just a grid. So we can just plug that grid into the merge. So now we're seeing this. And you see how quick this is to render. So it's just when you start getting to a really complex scene is when you kind of start to kind of have your tongue in the right place. So yeah, I don't know about the composition of this scene, but we've set everything up at least. I don't know either that I'm going to want to render the water like this, so stylized kind of. Probably want to start adding some materials, and we can just create something and change it later on. So I'm going to go material library is the way to add shaders inside of Karma or Solaris. And let's march the display flag to the material library. And then there's nothing on here. We're going to dive inside. And inside of this is where you set up your shaders. Now you can start going material and adding materials in here. But what we really want to do is to create something called a Karma subnet, Karma materialX subnet. And when you create that and dive inside and set up your shaders in here, it's going to have all the nodes supported by Karma filtered out. So there's no way you can add anything that's not supported. You can, however, add things that are only supported in CPU, but we're going to try to stay clear of those. So what I'm going to do is I'm going to get rid of the displacement, the inputs, and the surface, and the displacement output, because we're not going to use that. And into the surface output, we're going to plug a materialX standard surface. This is what is the best compatible with Karma XPU. And you'll see nothing changes. Let's say that this is for the pillars, and let's just make it a, I don't know, a darker gray and specular. Let's leave it at default, maybe lower it a little bit. So I'll go up, hit the U key, and I'll just say pillars material, and then I'll alt, click and drag, and let's make the ground material. And the ground material, I want it to be really rough, and let's set the base color to, I don't know, let's make an even darker gray. We'll probably figure out some nice colors in the end, but for now I'm out of ideas. And create the water material as well. Let's go in and, well, do we want to shade this as water, or do we want it a bit more stylized? This kind of black goop kind of thing. It's a good question. Let's go black and figure it out later. I want to make the back base color really dark and specular really low. So now that we've created all of these inside of our material library node, there's a really quick and easy way to just start assigning all of these. And that's by clicking the autofill materials button. You'll see that now there's one entry for each material. And there was no figuring out on your behalf. Now we just need to assign it to the geometry. So the first one is by default disabled, assigned to geometry. So I guess it would mean assigned to the whole scene. But we want to assign pillars, or the collider, to pillars material. You'll see how I can just judge, since I named my SOP import so descriptively, I can, in here in the scene graph, these are now the names or the path for each object. So I can go down and see the ground material. It's going to get the grid I created with the SOP grid. And once again, the water material is going to get the liquid shader. Or vice versa. The water material is going to get the liquid object. So now we have a scene. Starting to look a little more interesting. Especially once we get a little reflection into the object and the liquid. But this is just the start. Now we want to start figuring out maybe a better composition for the simulation, and maybe we want to figure out a slightly different appearance for the objects. And we have the freedom to do that in part 2 of this tutorial. I hope you found the tutorial useful. I guess it's pretty obvious I haven't used Houdini in production. I also haven't done a lot of Houdini tutorials. So this is kind of experimental, but it's something that's been requested. So I hope you want to, stay on this journey with me. And if you thought it was a good tutorial, then I'd love it if you shared it with somebody else. And if you thought there was anything I could improve, then let me know in the comments below, or to davesplaining@gmail.com, or through one of my socials as displayed on the screen right now. If you start creating something with this that you're happy about, also feel free to tag me or hashtag Davesplaining so I can comment and share your awesome work. If you find value in the stuff I'm putting out, please consider becoming a patron and supporting me. I've just done a revamp of the Patreon page. It's totally dead currently, but benefits include early access. You'll be getting to see the tutorials a few days ahead of everybody else. You can also utilize the Patreon video platform to see the tutorials. So at some point when I monetize this channel, hopefully, you won't have to sit through commercials if you're a patron. You're also gonna be getting access to scene files. I plan to do some exclusive content, maybe little BTS, just kind of ideas and work in progress, as well as setups that can make your life easier. You're also going to get, any of the scene files relevant for free, of course. And if I at some point do any premium courses, I might be sharing that or discounting that for my patrons. There's also Discord, which is empty, of course, but a good place to come in and ask questions about the tutorials or anything you're working on, give suggestions for upcoming videos, as well as just chatting about CG and, life in general. And I promise I'm not going to mute notifications or anything like that, so it's going to be the best place to get a hold of me. So thanks for your consideration.